Propositions and logic. What is proposition? Proposition is a declarative sentence or statement that can be either true or false, but not both in one sentence. So it can be either true or false. Proposition has a well-defined truth value. So meaning we will be dealing with the true and the false, or in binary, 1 or 0. Examples to make it clear. It will rain tomorrow. Yes, that's an example of proposition. Do you want to go out with me? No, it's not a proposition. A question is not a proposition. Interrogative, imperative, and exclamatory sentences are not propositions. Okay? Its form. We have now the simple proposition. One sentence. Now the simple proposition. To make it easy, simple sentence. Okay? For example of simple proposition. The sun is shining. Either true or false, right? What is compound proposition? If we will add an example on the simple proposition, let's add one. The wind is blowing. So we have now two simple propositions. The sun is shining, and then the wind is blowing. To make a compound proposition, we will be dealing with connectives. For example, the sun is shining and the wind is blowing. So we have no two simple propositions combined into one compound proposition with a connective and. Types in propositional logic. First, we have the negation. It can be applied in a simple proposition. Okay, we will add, for example, the symbol for the negation, and then the connective on this one with a clue is not. Example, the sun is shining. We will add not. The sun is not shining. Next is the conjunction. The common connective on that one for the compound proposition in the conjunction is the and. To make the grammar correct, others usually use also the but if it's contrasting idea and the as well as. If we will encounter the but and then the as well as, we will consider that one as connective for conjunction. Okay? This disjunction is very easy to remember since we are dealing with the or only. So conditional proposition, we'll be dealing with if-then connective. Okay? If, then. So we have now conditional. And the other one is the biconditional. If and only if. So we will make it clear for you to understand easily what will be the truth table or truth value of the compound proposition dealing with the different type of the propositional logic. Okay, let's start with, it's okay for the negation. Negation, if you find the symbol in this one, of course the negation is the opposite. If it's true, if our proposition is true, and then the negation of that one is false. Likewise, for the false, the negation is true. One type of proposition, the negation. We will have the opposite value of the proposition. Take note, simple proposition. Okay? If it's true, then if we're going to use the negation, false. The opposite, false and then true. Easy. Mostly we can use that one on the simple proposition. We will be inspecting the statement or the proposition if it has not. Examples of propositions. The negation. We will use the connective in the in words and then the in symbols. Okay? So in symbols, we will use the P, Q, R, and so on. We'll start with the P. And then for the connective, we will use the symbol for the negation, and then conjunction, disjunction, conditional, and biconditional. Our previous example is the sun is shining, right? Simple proposition, one sentence. And then to make it in a negation form, I type to the sun is not shining. We have the clue, not. Okay. And then, okay, for that on the simple proposition. So we will just going to inspect if the simple proposition is in negation or not. Conjunction. Very easy because we have the connected and or the but. In some instances, we can use also the as well as. Right? So in this one, the sun is shining and the wind is blowing. So we use the and connective. In symbols, P and then the symbol for the and then Q, because we have two propositions, P for the sun is shining and then Q for the wind is blowing. Biconditional, okay, unconditional. Let's start with conditional. If, example, if the book is interesting, then I will read it until the end. So there is a condition. And in the biconditional is a little tricky, but it's really easy to learn the differences between conditional and biconditional. Conditional. Example, if the book is interesting, then I will read it until the end. Symbol. Okay. Biconditional. The book is interesting if and only if I read it until the end. If I read it until the end, then the book is interesting. Okay, it doesn't change, right? Let's say the other way, the original one in the conditional. If the book is interesting, then I will read it until the end. Okay. To make it clear, so we will proceed to the truth table. Condition, of course, T to F and then F to T. Simple. And in the conjunction, okay, take note, we have now the instances of the combination of that two simple proposition because we're dealing with the compound propositions and for the conjunction. So take note, and for the conjunction. If we encounter this symbol, that is a conjunction, and the truth table on that one needs to be the compound or the result, okay, the final compound proposition is only true if the two propositions are both true. In conjunction, we need two true propositions to make the compound proposition true. And the otherwise is false. The remaining false. Example, TF, only one. So, false. False, FT, false. False, false. Of course, there's no T that is false. How about the disjunction? The disjunction. Or, and then, the truth table on this one, we will take note. Be cautious that we have to check only if there is one true value, either of the two. The first proposition is true, and then the other one is false. So the result is true. At least one. No need in conjunction both. You need both propositions true to have the result true. In disjunction, you need only one. It's either which proposition is true, then you have the result true. And the rest false. Okay, very easy. Conditional. The conditional now. Okay. The conditional, if then. Let's go to the then. If the then statement or the P is the F, okay? P, F, P, then Q. If the Q, the then statement is true, automatically in the conditional, the result is true, right? If it's false, the then is false, and then the F statement is not same with the value of the then. For example, the then statement is true. If the value of the P and Q are the same, for example, true, true, false, false, then we have the result. The compound proposition is true. What if they have not same truth value? For example, false then true, true and false. Then we'll look under this then statement. If the then statement is true, then the compound proposition is true. Okay? Same value, both same value, then result is true. And then if it's not same value, we will just look on the then statement. If it's true, then the compound statement as a whole is true. In the biconditional, we can interchange, for example, to test the proposition. If we can interchange using the if then biconditional proposition. Take note, if then, if P, then Q. If Q, then P. If they have the same thought, then logic, then we can say, okay, we can use the biconditional symbol or the biconditional connective, if and only if. What is the difference between the conditional and biconditional? Here in biconditional, we will only see or look at the same truth value. Okay? We will just look at the truth value of the propositions if they have the same. For example, P is true and Q and true. Right? P is true and then Q proposition is true also, then the result is true. If it's false and then the Q also is false, if they have unlike truth value, true and then false, then automatically the bicondition is false. Understood? Okay. Propositions and logic, we will try and analyze this one. The book is interesting. Let P and Q be propositions. The book is interesting. That is a P proposition. Next, the Q. I read it until the end. Okay, we have now two propositions, two simple propositions. We will combine that one using biconditional if, then, if and only if. Okay, we will use the biconditional if and only if because it doesn't change the thought on that one, the logic. Okay, let's test. In symbols, the P and then the P, Q. P, arrow, and Q. That is biconditional symbol. In words, the book is interesting if and only if I read it until the end. Alright, biconditional because we use the connective if and only if. The truth value on this one, if we have same truth value, if those propositions have same truth value, true, true, false, false, automatically the biconditional proposition is true, right? Otherwise, if different truth value, then false, right? Okay, example. The book is interesting if and only if I read it until the end. Therefore, this compound proposition is false if one of the proposition P or Q is false. Only be true either if both propositions P and Q are true, okay, or let's say the both propositions P and Q are false. So the book is interesting if and only if I read it until the end is true only if the both propositions have same truth value. True, true, false, false. Hoping you learned from this one, and then watch out for our next video because we will have to simplify the truth table of a complex symbols using the proposition and logic. God bless.